In the first lesson, you'll learn how to use the aggregate functions, what built-in aggregate functions SQL Server supports, how to use distinct with these functions, and how to use aggregate functions with nulls. SQL Server provides functions such as sum, max, and average to perform calculations that take multiple values and return a single result. These functions are used to aggregate or summarize the data that is stored in multiple rows. So far in this course, we've been using the where clause to filter rows. Let's say you need to count the number of rows that meet your criteria in the where clause. You can do that by using the aggregate functions in SQL Server. Now let's see how to work with these aggregate functions. Aggregate functions return a single scalar value, and when they are used in a select list, they do not generate a column alias. So when you use the aggregate function, you need to use the as clause to provide a name to the resulting column. Aggregate functions ignore nulls, except when using the count function. And they can be used in the select statements where a single expression is used, like the select, having, and order by clauses. Aggregate functions in the select clause operate on all rows passed to the select phase. If there is no group by clause, all the rows will be summarized. Having clause is frequently used with the group by clause to filter the data. To extend beyond the built-in functions, SQL Server provides a mechanism for user-defined aggregate functions via the .NET Common Language Runtime. Here are some of the aggregate functions that SQL Server supports: common, statistical, and other aggregate functions. The sum function returns the totals of all the non-null numeric values in a column. The average function returns the averages of all the non-null numeric values in a column. The minimum function returns the smallest number, earliest date time, or first occurring string in a column. The max function returns the largest number, latest date time, or last occurring string in a column. The count and count big functions return the count of all rows in the column. When you pass star as a parameter to these functions, the count of all the rows, including those with null, is returned. When a column is specified as an expression in the count or count big function, it returns count of all non-null rows for the column. Count returns the value as an int, and count big returns a big int. Now let's see some examples of these aggregate functions. Let's open a new query, and let's do a select minimum of the order date from sales.orders table. Click on execute, and it will give the first order date in the orders table. Let's change the function to max and see what the order date is. And it returns the most recent order date from the sales orders table. Let's do one more query. Let's select the average of the unit price, and let's call it average unit price, minimum of the quantity column, and maximum of the discount column, from sales order details table. Let's select this query and execute. And it gives us the average unit price and the minimum quantity and the maximum discount from that table. As you can see, we did not use a group by clause in this example. Therefore, all the rows from the sales order details table will be summarized by the aggregate formulas in the select clause. When using aggregates in a select clause, all columns referenced in the select list must be used as inputs for an aggregate function, or they should be referenced in a group by clause. Let's see what happens when you add the column order ID without an aggregate function and without using a group by clause. Let's select this query and click on Execute. It throws an error. To avoid this error, you can either group by the order ID or remove the order ID column. Let's remove the order ID and click on F5. Now let's see how to use the aggregate functions on character data. Let's do select minimum of the company name as the first customer and maximum of the company name as last customer. From sales customers table. Select this query and click on Execute, and it returns the very first customer and the last customer. You can also use other functions along with the aggregate functions. Let's do a select minimum of, and let's call the year function to get the year of the order date, and let's call it earliest year from sales orders table. Let's select this query and click on Execute. And it shows us that 2006 was the very first year in the sales orders table. So far you've seen how to use the aggregate functions. Now let's see how to use distinct with these aggregate functions. Earlier in this course, you learned about how to use distinct in a select clause to remove duplicate rows. When used with an aggregate function, distinct removes duplicate values from the input column before computing the summary value. This is useful when you wish to summarize unique occurrences of values such as customers in the orders table. When distinct is used in the select clause, it eliminates the whole rows, but when it is used in the aggregate function, it eliminates duplicate values. Let's take a look at a quick example. This query returns the customers that have placed orders grouped by employee ID and the year. Let's execute this query and observe the results. Let's open a new query. Let's paste the query here and execute it. As you can see, these two columns have different counts. The All Customers column returns all the rows except those containing nulls. The Unique Customers column excludes the duplicate customer IDs and returns a count of all the unique customers, which answers the question, how many customers per employee in that year? And as you can see, to get the unique customers, we've used the distinct in the aggregate function. Now let's see how to use aggregate functions with nulls. In the previous modules of this course, we've learned that it is important to be aware of the possible presence of nulls in your data and how nulls interact with T-SQL. This is also true with the aggregate functions. Most of the aggregate functions ignore nulls except the count function, which uses the star option. This means when a sum function is used, it calculates the sum for all the non-null values only. The presence of nulls in a column may lead to inaccurate computations for the average function, which will sum only populated rows and divide that sum by the number of non-null rows. This means that you need to use the isNull or the coalesce functions to replace nulls before using the aggregate functions. Let's see an example. Let's open a new query and let's do a select sum of C2 as some non-nulls, count of star as all rows, count of C2 as all non-null rows, average of C2 as average, and then sum of C2 divided by count of all the rows as arithmetic average from the numbers table where n is less than or equal to 15. Let's execute this query, and as you can see, the average and the arithmetic average are different. To make the average function use all the rows instead of just the not null rows, you need to replace the nulls with another value that can be used by the aggregate function. Let's see how to do that. Let's change the average of C2 to use a value of 0 when C2 is null and execute this query. And as you can see, the average and the arithmetic average are exactly the same.